Good afternoon, everyone. Welcome to day 4 of our week-long joint Institute of Asphalt Technology and Institute of Quarrying online conference in Achieving Net Zero. My name is Lyle Andrew. I'm Executive Director of the Institute of Asphalt Technology, and today's theme is alternative fuels and energy. Let me introduce, first of all, Dr. Richard Leese. He will be speaking on the role of fuel switching in net zero. Richard is a chartered environmental scientist at the MPA. He holds 2 roles, where he's Director of MPA Cement and Director of Industrial Policy, Energy and Climate Change. Following 10 years in the chemical industry, Richard joined the British Cement Association, which is now part of the Mineral Products Association, and has over 25 years' experience in environmental and industrial policy development and implementation. So with that said, it's looking forward to hearing this, Richard, and it's over to you. Thank you.
Thanks for inviting me to speak today about the role of fuel switching in relation to the energy transition and net zero. And firstly, I'll outline some context and then give an example of how fuel switching is being delivered in one of the MPA product groups, cement. And I'll focus on industrial processes. Many of you will already know MPA's trade association for aggregates, asphalt, cement, concrete, dimension stone, lime, mortar, silica sand industries. Got a growing membership of over 500 companies, and MPA covers 100% of UK cement and lime production, 90% of GB aggregates production, 95% asphalt, and over 70% of ready-mix concrete and precast production. And in 2018, the industry supplied £16 billion worth of materials and services and was the largest supplier to the construction industry, as we all know. Had an annual output valued at 172 billion. And as we know, we're the largest material flow in the UK economy at more than 1 million tonnes a day. So to provide some climate change context, the national context is, in terms of the UK's climate ambition, is made up of a series of targets comprising of different scopes and baseline years. And for some time, the UK's been a step ahead of other nations in terms of decarbonisation ambition. In 2008, you may recall that the UK became the first country to legislate for a carbon reduction target through the Climate Change Act. That target was set at the time at an 80% reduction by 2050 on 1990 levels. And as we all know today, the UK's climate ambition is net zero, and this is consistent with the temperature target set in the Paris Agreement to limit global warming to well below 2 and preferably to 1.5 degrees Celsius compared to pre-industrial levels. To get the UK on the net zero trajectory, the Climate Change Committee has advised that the UK greenhouse gas emissions reduction needs to be strengthened to 78% reduction by 2035 from the 1990 baseline. So at the national level, we know where we're heading, and obviously COP26 is currently meeting. But on the run-up to COP26, we've seen the UK government and some of the devolved governments publish strategies and plans, and one of which is the Prime Minister's 10-point plan, the Energy White Paper, the Industrial Decarbonisation Strategy, which features a cement kiln on its cover, the Treasury Net Zero Review, and most recently the Net Zero Strategy. And all of these are important because they will affect how concrete, cement and other minerals are made, transported and used. Last winter, we saw the Energy White Paper set the scene for the transformation of the energy system. It outlines how by 2050 our coal use will reduce to zero, and how hydrogen as a fuel will go from pretty much zero to 20 to 35% of the final energy demand. As the transport and as industry electrifies, the power grid will need to be between 2 and 3 times the scale of the current grid. That's quite staggering change in just a few decades. The policy drivers and the need to get to net zero mean big changes for energy intensive production processes like cement and lime. It means changes to fuel sources for the processes, for transport and machinery, but it also means changes to the carbon profile of power consumption and having to deal with the consequences of a system with higher levels of intermittency as a result of renewable energy, and a system where increased demand side responses are needed to modify consumption patterns. The chart on the left-hand side shows that the UK concrete and cement industry are decarbonising faster than the UK as a whole, when measured on the same basis as the UK's national greenhouse account that feeds into the UN process in Glasgow this week. The early action that has already been taken includes improvements in energy efficiency. That's a shift to modern dry process kilns in cement production, as well as investment in energy efficient plant and machinery. Also fuel switching. So 47% of the energy demand in UK cement kilns is now from fuels other than the traditional coal. There's also been changes in product formulations. The clinker content of both factory-made cement and in concrete is less because cementitious or cement-like replacement use has increased. The donut chart on the right-hand side shows that the UK concrete and cement emissions are around 1.5% of the total UK emission. That's 5 times lower than the global cement industry contribution. The cement and concrete industry roadmap to beyond net zero outlines how that 1.5% becomes zero and how we can contribute to emissions reduction in other sectors. So in October last year, MPA launched that roadmap. So it's the UK concrete and cement industry roadmap to beyond net zero. It represents a significant milestone for the cement and concrete sector, and it clearly sets out how the sector can contribute to and even go beyond net zero by 2050. It identifies what is needed from industry, but also government and other stakeholders to get there. The waterfall chart is the key graphic in the roadmap and very simply shows the contribution of each of the levers. It shows on the left-hand side where we've come from, which is the 1990 emissions level, which is also the baseline used by the UN and UK government, where we are, which is the kind of 2018 reference point, and what is possible where each of the reduction levers are expressed as a percentage reduction against that 2018 reference point. It's important to recognise that this is just one of the possible routes to net zero, and as some technologies develop and we learn more about the potential of others, things will change over time. So the kind of annual version of this chart to 2050 looks quite different. Fuel switching is one of the major contributors to the overall net zero journey and is one of the levers that we are and can pull on right now. I'll outline what we're doing in terms of fuel switching and some of the fantastic innovations being made. You'll often hear in the media that globally the cement sector contributes 7% of global emissions. However, in the UK, as I said, that number's 1.5%. This image shows the part of the cement and concrete supply chain where I'm focusing my attention today, which is the calciner and the kiln, where the majority of fuels are consumed in the thermal combustion process and where the majority of carbon dioxide emissions are produced. 30% of the emissions arise from the combustion of fuels, and the remaining 70% arise from the breakdown of calcium carbonate raw materials, so-called process emissions. So as you can see, with total emissions of 6.6 million tonnes, a net zero fuel mix can reduce emissions by around 2 million tonnes annually. That's about 750,000 homes. There's all the information popping up. Traditionally, cement manufacturers relied on fossil fuels like coal and petcoke. However, since 1990s, fossil fuels have been gradually replaced by waste-derived alternatives. In 2020, 47% of the thermal input in UK kilns was provided by waste derived fuels. That's 600,000 tonnes of waste and equivalent, and that leaves about 500,000 tonnes of coal in the ground each year. Around 18% of that thermal demand comes from waste biomass sources, which is important in the context of net zero, as biomass sources have already undergone a use or a function in the economy. Fuel use in cement manufacture has dual purpose, the energy value, but also the mineral content. And each year, around 160,000 tonnes of fuel ash is essentially recycled into cement. So returning to the roadmap and the role of fuel switching, a considerable amount of fuel switching has already been achieved. Our roadmap kind of models around 70% waste biomass fuels and some thermal efficiency savings to get where we want to be. The roadmap doesn't assume that all this can magically happen. A series of enablers are necessary to help deliver it. The sector needs support to access waste biomass. This has to be, equivalent to that, received by other consumers like power generation. And we await with interest the government's biomass strategy due next year. The production of hydrogen via low or zero carbon means is required at a cost that won't affect the competitiveness of the sector and in quantities that make it viable as a fuel use. So we're not just writing about the plans we've got for fuel switching, MPA is delivering on it. Our innovation programme is in full flow. And just a few weeks ago, we achieved a world first. The journey started a few years ago with a feasibility study to investigate an idea that I had. And that idea was to net zero fuel UK cement kiln with a combination of biomass, hydrogen and electrical energy. We carried out a feasibility study, and that concluded that it was theoretically possible. The feasibility study set up an application for government funding to demonstrate the theory. The demonstration is split into two parts, a trial of hydrogen and biomass at the Hanson-Ribblesdale plant on the main kiln burner, and a trial of biomass and electrical plasma energy in the plant calciner at Tarmac's Tunstead plant. MPA's main project partners, obviously Hanson, Tarmac, CNAR for CFD modelling, and VDZ consultants from Germany. And they deployed a number of engineering changes at Ribblesdale, where we've just recently completed the trial. Changes to the biomass delivery system to accommodate glycerine and analyzer upgrades to capture any potential alterations in the kiln operation from the new fuel mix. Demonstration included 4 fuels: coal, as we dropped off coal, hydrogen, meat and bone meal, and glycerine. Glycerine was delivered and stored in road tankers and delivery to the kiln using the existing waste liquid fuel system. Hydrogen was delivered by road, and at full flow we had 9 trailers over a 5-hour period. And that's because you only get 250 kilos of hydrogen on a trailer. And obviously the safety precautions were extensive and thorough throughout. Needed a whole new manifold system for the hydrogen delivery. So this was the moment when we achieved proof of concept to net zero fuel the kiln main burner with a fuel mix of 47% hydrogen, 12% meat and bone meal and 41% glycerine. It was truly a groundbreaking world first achievement in Lancashire, with a small number of happy and emotional people to witness it. And I say the emotional because they knew that it was a real game changer for the industry. And there was the odd tear in the eye, I have to say. So thank you. There's still obviously a long way to go before we start seeing 100% use of zero carbon fuel, especially in large volumes, including large volumes of hydrogen. But what we've seen in the cement industry just recently are important first steps. And we know there's much more that government needs to do, including funding for fuel switching. We know that there are some new funding streams available for that. So hopefully that's given you an insight into how UK cement industry is dealing with the energy transition and switching away from fossil fuels to lower carbon and net zero fuels.
Question from the chat. According to the American Chemical Society, there's a possibility that adding more water vapor to the atmosphere by burning hydrogen could produce a negative feedback effect. Is that something? Is it actually a thing, and should we be worried?
Water vapor is a greenhouse gas. It's probably one of the most important greenhouse gases in the fact that it's water vapor that keeps the atmosphere relatively regulated. But it's a balance, isn't it, between the carbon content versus other environmental impacts. I'm not seeing at the moment that would be a barrier to using hydrogen.
You talked about biomass fuels. Other industries will also be looking at biofuels. Is there enough to go around?
It's a really good question. And the kind of biomass that the cement industry is most interested in is the waste biomass. So that it's stuff generally that's either gone through a use in the economy already, and therefore there is an environmental responsibility associated with that first use, versus kind of new biomass. The kind of leveling trees and using that. Now, we use the waste biomass. Certainly, the biomass we used in the Hansen trial was glycerine, which is a byproduct of biodiesel production. So if we do increase biodiesel production, then there is an opportunity there to use one of the waste products in cement production. We do await the government's biomass strategy, which will be coming out in 2022. That really needs to kind of start tackling some of the waste biomass issues, because traditionally, any kind of commentary coming out of government has been generally tree planting and timber production related, rather than looking at the biomass system as a whole. But if we're moving away from single-use plastics, and obviously that's a good thing in nearly all the cases, I would guess, then we're going to end up with more cellulose type matter in the waste system. And we know already that the pulp and paper sector can't recycle into other pulp and paper all of the waste cellulose that's generated. So why not use it to replace fossil fuels? And then we've obviously got the added bonus that we can capture the CO2 from that biomass consumption, or combustion rather.
Thanks, Richard. Obviously, we're seeing really high energy prices at the moment. And what is this going to do to the energy transition?
It's an important question. I mean, we've seen unprecedented gas prices over the last few months, and that's had an impact on electricity prices and also UK CO2 prices. So the impact of that rapid change in the energy system has been kind of widely felt, and obviously a number of domestic suppliers gone to the wall because of it. The UK is quite vulnerable in my view, in terms of we only produce around half of the natural gas that we consume in the UK. That makes us vulnerable to LNG imports. At the moment, we know that there's high global demand for LNG. When a ship's on the high seas, it will go to the highest bidder, even if it's kind of routed towards the UK. It can always go somewhere else. That makes our system quite vulnerable. And I one of my kind of other duties, I guess, is I chair the energy intensive users group, and we've been lobbying on behalf of mineral, steel, glass, ceramics, and other industries for government to tackle the issue, not just for this winter, but also some of the underlying structural changes in the energy system that have over more than a decade separated the UK's energy prices from the kind of EU mean. And this episode that we're seeing right now is only going to seek to put another dot on that chart, whereby UK prices are diverging away from a European mean. So it is something we need to tackle, because otherwise we'll see more of these kinds of episodes in the energy transition as coal comes off power generation and more countries go after gas, then we'll certainly see more of this type of episode.
Thank you very much.